guess many of you knows Airbus. For sure, you think about the civil aircraft. Just a reminder that there are also other type of flying platforms in the air, like helicopters or military aircraft. Also, stuff flying in the space, satellite, and also activities around really communication. And for all these applications, artificial intelligence is bringing new kind of value. So I will just remind what we mean by artificial intelligence inside Airbus. For sure, we can discuss a lot about definitions and so on, but for sure, for us, it's about providing assistance to perception task. And depending on the type of data, it will be more computer vision, or if we are with sensor data, it will be more pattern recognition or time series analysis. If we are with text or speech, it will be about natural language understanding and processing. We also try to provide assistance for prediction based on data-driven on physics-based model, doing hybrid modeling. And also, we try to provide assistance for the decision-making, looking at offline decision-making, planning, scheduling, but also potentially a closed-loop system. So really looking for control on how we can use AI for improving control. So we do use data-based artificial intelligence and symbolic artificial intelligence. It happens that we use more the data-based approach for the perception aspect because this is where it has been outperforming recently on a lot of benchmark. And still on the decision-making, it's more symbolic AI, but often a mix of both approaches is required to provide to provide what we need. So today we already use a lot of artificial intelligence inside Airbus, but mostly for non-critical applications. So the example you see on the top left is where we are. So we have today a platform called One Atlas for space imagery. And already we use a lot of artificial intelligence to extract information from this image, like detecting objects, cars, buildings, ships, aircraft, on many other things, on doing analytics on top of that, also doing change identification between consecutive images. And this is already something which is deployed. Also, we have another platform which is really for more topic linked to predictive maintenance for the fleet of Airbus commercial aircraft, where we are capable to really analyze sensor data coming from fleets of Airbus aircraft, and where we can potentially do health management on predictive maintenance. So this is where we are. Where we want to go is really using also artificial intelligence for critical applications. And you have some example of critical applications which are mostly linked to image because this is more easy to show in the presentation, but we do have we really want to address the full range of speech, natural language, speech text, so natural language processing, and also sensor data. But let me go through this example with images. So the first one on the top right is about automatic air-to-air refueling. So already today we demonstrate we can use image-based processing for the guidance of the boom, which is this device which goes from the tanker to the fighter to do the refueling. Another example is for helicopters. We do have also helicopters which are equipped with cameras to detect the helipad and to do autonomous landing. And this is an ongoing research activity. And the last topic is really something where we have made demonstrations last year about autonomous taxiing, takeoff and landing of commercial aircraft using also vision-based capability. So you have examples there where we detect obstacle. I mean, we detect items, objects on the taxiway. And also for the landing, we are able to detect the runway itself and to use that as an input to the control law for doing autonomous landing. So it's not an exhaustive list, but for sure for all these applications, we need robust artificial intelligence. And this is a challenge to us as industrial, but also it is a challenge for the regulation, the regulator, because each of these applications is discussed with a regulation authority. So we'll come to that later on. So to make it simple, when we look at our research axis inside Airbus, we want to go towards safety critical, and we also want to go from on ground to on board. On this aspect of going on board brings challenge because the kind of hardware we use on board is very different from what we have on ground. And also the hardware itself is subject to certification. So as of today, using a GPU on board for for safety critical application is not an option. So we are still using hardware which are really where we can demonstrate a real-time capabilities. And so we have also to work on this aspect of embedded artificial intelligence. And it could be embedded for flying platform. It could be also, I mean, we have aircraft, and we have also space applications for which there are even other constraints in terms of hardware we can use. So, I mean, like it was said before, I mean, we are facing somehow a dilemma because today if we compare symbolic AI, so rules written by humans, on data-driven AI, where we learn from data, in terms of performance, with symbolic AI, we have some level of performance, and we know where we are in terms of guarantees because we know how to deal. The system is following the rules mostly which we provided, so we know what level of guarantee we can achieve. With data-driven artificial intelligence, performance could be better, and especially for perception task. But level of guarantee is the open question. And for us in Airbus, I mean, the key aspect is safety first. So we really need to find the right trade-off, not compromising in any way the safety. And we will show you how we plan to achieve this. So if we look to the different kind of application we have of data-driven artificial intelligence, we have quite different type of applications. So we have, for example, what we can call shallow neural network, or maybe less deep neural network that can be used to approximate complex functions, tables, physical models. So there is an example here, which is the ACAS XU functions for avoidance. And in order to run the inferencing on board, it's quite convenient to rely on a neural net, which is a very compact approach to bring the function on board. And this is not a deep neural net. So for this kind of use case, you can do, or you can already achieve some level of result using formal verification. But also you can try to see what happened with adversarial machine learning, and you can also do massive testing. So the question is really how you can combine the different approach so to provide the more guarantees about the function. And for other kind of applications, such as using a deep neural network for vision-based navigation, the example I provide here is about detecting the runway. Here, the network is very deep. So for sure, the aspect of doing massive testing with real and synthetic data is the de facto option to start with. But also, we are trying to use adversarial machine learning to understand the impact of noise or adversarial examples. We wish we could use also formal verification on some of the aspects, but as said in the previous presentation, we are facing scalability issues. But that's why we want to work closely with academics, because ultimately, if we would also be in a position to use formal verification, including on some of the image-based processing application, this would be very interesting for us. So today, I mean, I put a question mark because and it's the objective of this workshop is we try to define what kind of decision tree or more hybridization approach we can use between the different solutions which are developed in the community, in the research community. Today, we already work with some partners, and yeah, this is not an exhaustive picture, but just to show you, we are partnering first with the regulation authority. So if you look on the bottom of this slide, our products are regulated. So we have to work with EASA for civil aviation, but also with EUROCAE, with the national also aviation authorities such as DGAC, DFS, and so on. So this is for civil aviation. We also work with space regulatory bodies such as ECSS, which is with European Space Agency. And on the bottom left side, we have also all the discussions with Ministry of Defense and military applications, where we have to regulate the way artificial intelligence would be used. So this is one important set of stakeholders. Then we have the academics, which are key to us because, as I said, we hope we can evolve the state of the art, and we've put there some labs and teams where we already either we work with them or we wish we could work with these different teams. And I will come to that later on. We have a set of collaborative projects where some of these teams are already involved. Then on the tech company, there are the big tech companies, Facebook, Google, Amazon, and so on. And we somehow try to reuse what they do, but on the topic of robust AI, this is really a domain where we believe we have to build together with academics a new set of tools, because we cannot expect the GAFAs will develop such functionality off the shelf for us. And to do that, so we also partner with other industry. So automotive industry was the previous talk. So we share for sure some concerns with automotive industry, but also we have partner in the railway industry, other aerospace in partners, also energy. I mean, a stakeholder. I mean, industry partner in the energy domain. So, and for sure, I mean, I've had the stickers at your organization here because we are very open to really embrace new contributions. As of today, we are involved already in some collaborative research project about certifiable and trusted AI. So these are the major ones. So we have in France the ANITI Institute, which is one of the national artificial intelligence institute, which has been recently launched. On ANITI is focusing a big part of its activity on bringing AI to safety critical application. We have also the Confiance.ai project, which is targeting more the way we would integrate artificial intelligence to engineer safety critical systems. So somehow taking the results of ANITI, but bringing them into an engineering framework that our engineers in Airbus could use, because we don't expect it should be always used by data scientists and the really experienced workforce in AI, in artificial intelligence. We want to democratize the way we would do trusted artificial intelligence. And we have the DEAL research project, which is a Franco-Canadian project, which works together with ANITI, but also having partners in Canada, such as CRIAC and Mila. And so also in Germany, we are part of a specific project targeting certifiable AI, which is just starting. At European level, for sure, we were part of the high-level expert group on artificial intelligence. And there are two network of excellence. One which is Human AI Network, which is about really human agency aspect on the ethics, let's say. On Taylor, which is more about trusted AI aspect, where many labs are active in this network of excellence, and this is also an entry point for us to collaborate. Speaking about the DEAL project, so DEAL stands for Dependable and Explainable Learning, and one of the activity which was performed on the which will become public was to really look at what are the challenges for using machine learning in certified system. So the focus was a bit reduced to using offline learning. So we train a machine learning model, and then we do a model freeze, and this is deployed, implemented in the platform and there is no retraining of the model. So the model is somehow deterministic. And we also make a restriction to look for supervised learning. And having taken this hypothesis, there was an analysis which was made inside the DEAL project to really look at what are the challenges. This is a view of the document which has been issued for the consortium already and should go public by the end of this month or quite soon, let's say. And this was an opportunity really to look at all the challenges we have to use machine learning in certified system. So I will quickly highlight these challenges. The first one is about probabilistic assessment. For certification and for machine learning, we use probabilities, but not using the same words for the same meaning. So there is something to be built to bridge the definitions on the way probabilities are used in both worlds. And it's still open, I mean, some of the aspect. The resilience aspect is really how you can design a system that will be resilient, and especially if you know when your machine learning system is not working as you wish. There are many ways you can still ensure the resiliency by doing monitoring of the performance of the machine learning model and potentially switching to a fallback solution that would use a traditional implementation. And so there is a topic really about how do we ensure the resilience. Specific ability is a big asset because today the certification is done in a way that somehow we verify that the code has been implemented in the right way. And for sure, if we go with data-driven AI machine learning, the code is generated by the algorithm. So we are back to the specification. It should be more focusing on the training data sets. And this is a new approach, also a new approach for the regulation. Then the other one are pretty known to you, I guess. For sure, we have to manage the data quality and the representativeness. We have to deal potentially with explainability, with the robustness, which is the main topic for our workshop, on the verifiability property. So when we are in Airbus, so for sure we do look at what we call trusted artificial intelligence algorithm on the associated development framework. And this is really the scope of the workshop, bringing new guarantees on top of artificial intelligence algorithm. But this is only one of the aspects of what we need to do. Also, we really need to look at the way we would potentially onboard these algorithms. So what kind of hardware we can use to implement that on board, or we can generate the code for this embedded platform. And we need also to rethink the way we do system engineering for safety critical system, starting from the requirement. If we know we will have to provide evidence about the training data which was used to train the system, this is a new requirement which we need to take into account, and there are many other requirements which we need to take into account if we want to include AI in safety critical systems. So we really need to rethink this aspect. We need to think about architecture design patterns for fail-safe AI. So this is about providing the resiliency at system level. We need to work on the V&V method, on a lot of the tools which are developed in the research community could provide methods, technology that we can use for the V&V. We have to perform the certification process, and we have really to discuss what it should be with the regulation authority. And last but not least, I mean, in terms of what we do, not everything is subject to certification, but everything is somehow regulated. So we need to really work on this, on the regulation aspect, on the standards, also to potentially improve efficiency. So we are active on all these topics. For the workshop, the main aspect is the first topic, really discussing on the algorithm. And I want to introduce, I mean, you already have had the chance to listen to some of the people who are involved in the artificial intelligence research team, working on some topic to improve the robustness. So we are working on really the aspect of doing safe surrogate models, robust estimation of risky situation, doing the conformal prediction. And this is the main topic for Giant. We are working also, we are investigating Bayesian approaches to do variational inference out of distribution, detection, on trust scoring. And this is the topic of Joseph. I don't know if Joseph is already with us today, I guess so. When looking also at, we are also looking at identification of vulnerabilities, and this is the main topic for Audrey, adversarial machine learning, and also all means we can use to do strengthening. On the topic of formal robustness with Melanie. So looking at different approach using constraint solving and also other approximations. For sure, the artificial intelligence research team is the one organizing these workshops with you. We do have also researchers which are involved in the different collaborative projects, which I mentioned before. But we wish we would have a good exchange with you during these 3 days, really to move forward, because we believe we have a journey together to accomplish, and this is my last slide. Because yeah, we on the one side, academics, tech company, and some of our researchers are building new trusted AI methods, but we need to integrate these trusted AI methods in our to integrate them in a way we can use them for engineering safety critical systems. And for that, we will use this trusted AI method to provide demonstrations of the performance, but also of the guarantees we will have. On taking the journey the other way, I mean, we have to work with regulation authorities, which need to ensure, and we need to ensure with them, that we will have safe and efficient operations. And from that, we need to decline what we should demonstrate. And today, it's really about finding the right match between what we can demonstrate and what we should demonstrate. And as I said, this is a journey together, because we don't have unique answers at the moment. We are more in the exploratory phase, but we have also a challenge coming, because if we, I mean, I can link to the EASA roadmap presentation from Guillaume. We will see that the timeline we look towards to is a quite ambitious timeline. So we hope we will find results on win-win situation, always maintaining the safety levels in the next decades, for sure. Decade, not the next decades, but the 10 years from now. And yes, we are very happy to collaborate with all of you. And I'm happy to take some questions now. This is the end of my presentation. Thank you.